FastMCP 3 implements a reactive state management pattern through declarative tool invocation, where asynchronous server calls are orchestrated via callback handlers that update UI state and trigger user notifications. This artifact demonstrates the core mechanism for handling success and error states in tool calls, using a compositional approach that separates concern handling from the tool execution itself. You're about to examine how a CallTool invocation specifies success and error callbacks that will modify application state and display toast notifications, with the success handler updating a state variable using the reactive result reference. The code will reveal the precise callback chaining pattern that ensures state consistency and user feedback after asynchronous operations.
From Prefab UI, Actions import SetState, ShowToast. From Prefab URX import result. CallTool. Save contact. OnSuccess equals. SetState contacts, result. ShowToast saved. Variant equals success. OnError equals ShowToast. Something went wrong. Variant equals error.
This code demonstrates a declarative approach to handling asynchronous tool call outcomes in a reactive UI framework. The CallTool function initiates a server-side operation, save contact, and specifies callbacks for success and error states. On success, it updates the application state with the result using SetState contacts, result, and displays a success notification. On error, it shows an error toast. This pattern clean lines separates the tool invocation from its side effects, making the control flow explicit and maintainable. The use of result as a reactive reference to the tool's return value is particularly notable. It allows the success callback to access the resolved value without manual promise handling, which simplifies the code while maintaining reactivity. The error handling is similarly streamlined, using a single action rather than a callback list since no state updates are needed on failure. This approach balances conciseness with clarity, as each callback handles exactly what's needed for its respective state. The design reflects a common trade-off in reactive frameworks: explicit callback chains versus more magical reactive bindings. Here, the explicit on-success and on-error lists make the data flow obvious at the cost of slightly more verbose code. This is often preferable in production systems where maintainability outweighs brevity, especially when multiple side effects like state updates and notifications must coordinate after an async operation. Let's break it down.
From Prefab UI, Actions import SetState, ShowToast.
Imports two action classes from the Prefab UI module: SetState for managing component state and ShowToast for displaying temporary notifications.
From Prefab URX import result.
Imports the result constant from the Prefab UIRX module, providing access to a predefined value used for reactive programming patterns in the UI framework.
CallTool.
Invokes the CallTool function with no visible parameters in the provided segment. The function call appears incomplete as it lacks closing parentheses and any arguments, suggesting this may be part of a larger expression or a syntax error in isolation. Without additional context or parameters, the observable behavior is simply the initiation of a CallTool call.
SetState contacts, result.
Updates the state with key contacts using the value stored in the result variable. This operation stores the result data in the application state under the contacts identifier, making it accessible elsewhere in the application through the state management system.
ShowToast saved. Variant equals success.
Displays a success toast notification with the message saved, using the variant parameter set to success to indicate a positive outcome.
OnError equals ShowToast. Something went wrong. Variant equals error.
assigns an error handler that displays a toast notification with the message, "Something went wrong," using the error variant styling when an error occurs. FastMCP3's reactive state management shines through its declarative tool invocation pattern, where CallTool orchestrates asynchronous operations with explicit success and error callbacks. The success chain updates state via SetState, contacts, result, and provides user feedback through ShowToast, while the error path simply displays a notification. This separation of concerns keeps the control flow transparent and maintainable. The result reference is key here. It bridges the async operation's return value to the reactive state update without manual promise handling, simplifying the code while preserving reactivity. The design favors explicit callback lists over implicit reactive bindings, trading slight verbosity for clarity, especially when coordinating multiple side effects like state updates and notifications. This approach aligns with production systems where maintainability outweighs brevity, ensuring state consistency and user feedback remain tightly coupled, yet cleanly separated.
The toast materializes from saved contacts, while errors vanish into the on-success void.